Problem 36. Use the diagram below to answer the question that follows. All right, there's my diagram. A gift box has dimensions x by y by z. A decorative ribbon is wrapped across the diagonals of the box as shown above. Which of the following expressions represents the approximate total length of the ribbon? All right, so let's just measure this ribbon. So what's this length right here? What's that length right there? Well, if we draw that side of the box, the height is z, and the depth is y, and the ribbon goes from the bottom left to the top right. From the bottom left to the top right. So we can use a Pythagorean theorem right here, right? Because if this height is z, then this height right here is z. So this is a right triangle, and so we can figure out the hypotenuse using the Pythagorean theorem. So we could say that the length right here, the length squared, maybe I'll write it like that. The length squared is equal to y squared plus z squared, or the length is equal to the square root of y squared plus z squared. That's this length right here. Now, we can use that exact same argument on this side of the box, over here. You can imagine just if we were to face it, well, if you were to just turn it around, it would look exactly like this. Or if you were to look at it from the inside of the box, it would look like this. It looks like this is the back of it. So if we're looking at it from this direction, it looks like this. The height is z, the base is y, and so we just have the hypotenuse. Y squared plus z squared is going to be equal to the length squared, or the length is equal to y squared plus the square root of y squared plus z squared. So that's this length and that length. So far, if we just want to add up just that length and that length, we're going to have 2 times each of them. So 2 times the square root of y squared plus z squared. That's the two red parts of the ribbon. Now, what is this length right here? Well, same argument. If I were to just draw the base of this rectangle, the depth is y, the width is x, and the ribbon just goes across it like that. The ribbon just goes across it like that. So if we call this the length L of this blue part, you have L squared is equal to x squared plus y squared, or L is equal to the square root of x squared plus y squared. That's this length right there. And then this length over here might not look the same because of the way that the perspective works, but it's the exact same thing. It's the exact same thing. If this is x, this depth is y. If you were to look at the box from the top, this length is x, the depth is y. That top ribbon looks like that. So x squared plus y squared is going to be equal to that thing. So this length is also the square root of x squared plus y squared. So that's the square root of x squared plus y squared. This is the square root of x squared plus y squared. So in the total length of the ribbon, we're going to have 2 of them, plus 2 times the square root of x squared plus y squared. So the total length of the ribbon, 2 times the square root of x squared plus y squared, plus 2 times the square root of y squared plus z squared. Now, let's see. That looks like choice C. They just factored the 2 out. So it's 2 times everything. Square root of x squared plus y squared plus the square root of y squared plus z squared. Right over there. Next problem. Problem 37. Use the graph below to answer the question that follows. All right, we have this little drawing of a hand pointing up. If the image of a pointing hand in the graph above is rotated 180 degrees about the origin and then reflected across the x-axis, which of the following graphs will result? So let's do it step by step. If you're rotated 180 degrees, you're rotating it like this around the x-axis. You're rotating it like that. So for example, this square, you could draw it. We'll do it in a lighter color. This right here, this part of the hand is going to rotate it all the way down. So it's going to look like that right there. If I were to shade it in, and then the hand, this part right here is going to be rotated all the way down like this. So the hand's going to look something like this. That's the thumb part. And then you're going to have the finger coming out like this. The finger part, the finger pointing up, and then you're going to have the other finger. So the hand's going to look something like that when you rotate it 180 degrees. I just rotate it around the origin. Now, the second part is then reflected across the x-axis. So then if we reflect this across the x-axis, it's going to look like this. It's going to look something like that, like right there. So that should be our answer. So which of the choices looks like that? Looks like choice C. Choice C looks exactly what we drew up here, where the finger is closer to the vertical axis than I guess the pinky is in either case, because we rotated around and then we flipped. And that is choice C. Next question. Next question. Problem 38. Which of the following nets can be folded to form a square pyramid? So a square pyramid, so this is all, they're giving us some visualization problem. A square pyramid is just a pyramid that has a square as its base, like the pyramids in Egypt. So it has a square as its base. So it has a square as its base. So that's the square base. Let's see if I can construct one. If I were to fold this guy up and then this guy up, then can this guy be the other side of the pyramid? No, because if I fold this guy up like this, so let's say imagine, let's fold him up. And so I have a pyramid, so this guy gets folded like that. And then this guy over here, can he fold in? He's going to fold straight down and fill that up. So this guy right here can fill that right there. Maybe, yeah, let me use some colors. And then if this guy, when I fold it, will fill right there. And then this flap won't fill in the blank. This flap won't go where it's supposed to. That's it. This flap will just recover this flap again. So choice A is not the correct choice. Let's see choice B. So if I flip this over, that flap is just going to go right there. So that flap is going to go right there. And then let's say this flap is going to go over right there. And then this flap right here, let's see if this flap, this side right there is going to be that side. So this flap is going to go right over on this side just like that. And then this last flap, remember this edge is that edge right there. So this last flap will just fill in the blank right there. So it looks like B works. We'll actually form a rectangular or a square pyramid. Let's see if these other ones work before I rule them out. So this flap over here, this top flap, when you flip it over, is going to, you can imagine looking at the pyramid from the top. And then this edge over here, let me do it in pink, this edge over here would flip down and fill up that edge. But then this edge right here will just, when you fold this, will just go on top of that same edge again. And then this over here will just go over on top of this edge again. So we're only going to get half the pyramid, so that's not going to work. This one, you flip this one over, it's going to look like that. Imagine looking at the pyramid from above. Then you flip this one over. It's going to look, let me switch colors. It's going to look like this part right here. And then this piece, let me do it in purple. This piece right here, because this edge is going to be this edge, is going to fill that right there. But that's exactly where this piece would go when you flip it. So we're going to have an empty space right there. So that also doesn't work. So B is our answer. Next problem. Use the figure below to answer the question that follows. Okay, they give us a little triangle. If equilateral triangle ABC, well, equilateral tells us that all the sides are equal, represents one of two congruent halves. Congruent means completely sides and angles are the same. Congruent halves of a figure that has AB as a line of symmetry. So AB is a line of symmetry, and this is half the figure. So the rest of the figure is going to look like this. So the line of symmetry, so you literally just, the line of symmetry is going to look like that. It's going to look like that, and that length is equal to that length is equal to that length is equal to that length. So all four sides are the same. Then the entire figure is, well, all four sides are the same. It's a little bit skewed, so it can't be a square, but it's going to be a rhombus. A rhombus. Problem 40. Use the diagram below to answer the question. Well, we know how to do that. Three straight lines intersect to form a triangle, as shown above. What is the measure of angle x? Well, here we just use a couple of our angle rules. If you watched any of my videos in the past, it's what I call the angle game. Let's play the angle game. We have 60 degrees here. This is opposite to the 60. It's going to be the same angle, so that is also going to be 60 degrees right there. This is 115 degrees. it is going to be supplementary to this angle right here, which means that this angle plus 115 is equal to 180. So if we call this x, x plus 115 is equal to 180. Subtract 115 from both sides. X is equal to 80 minus 15 is what? 80 minus 10 is 70. 70 minus 5 is 65. So this angle right here is 65 degrees. And this angle, let's call that y. Y plus 65 plus 60. And I don't want you to confuse this x with that x. I probably should have called that some other number. But I'm just saying 65 plus 175 is going to be equal to 180. That's how I got the 65. They're supplementary. And now let's figure out what this angle y over here is. Y plus 60 plus 65 has to be equal to 180 because they form a triangle. The angles in a triangle add up to 180. So y plus, add these two together, 125 is equal to 180. Y is equal to 180 minus 125. See, 80 minus 25 is what? 55. So y is equal to 55 degrees. We're not quite done. Y is equal to 55 degrees. Now, x is supplementary to y. So you say x plus 55 is equal to 180 degrees. Well, we already know what plus 55 is equal to 180. 125. So we say x is equal to 180 minus 55, which is equal to 125 degrees. Just choice C right there.